to find the antiderivative of 1 over sine x minus cosine x minus 1. First, you're going to set u is equal to tangent of x over 2. Then using arctangent, you're going to solve for x, and you're going to get x is equal to twice the arctangent of u. Right? Arctangent means that the tan will be gone. Arctan u will be equal to x over 2. Isolating u by multiplying both sides by 2, you will get x is equal to twice arctangent of u. dx is going to be differentiating both sides, right? 2 over 1 plus u squared du, right? Because the derivative of the arctan is 1 over 1 plus u squared. With that 2, it gives you 2 over 1 plus u squared du. So now we need sine x and cosine x, right? So sine x, using this equation here that we used for dx, we're going to use it for sine x. Sine, right? Sine on both sides. Sine of twice the arctangent of u. Not sine x. Sine, yeah, just the sine. So you know that the double angle formula says that it's going to be twice the sine of arctan multiplied by the cosine of arctan. Okay, so that's the cosine. So now how do you find the sine? Arctan u means angle whose tangent is u. So suppose this is the angle, the tangent will be u over 1, right? Which will give you angle whose tangent is u, opposite over adjacent. This side, using the Pythagorean, must be square root of 1 plus u squared, right? So sine of this will be sine will be opposite over hypotenuse, right? So u over square root 1 plus u squared, and then adjacent for the cosine, adjacent over hypotenuse, 1 over square root 1 plus u squared, right? Which will give you 2u over the square root is gone, 1 plus u squared. Perfect. Now what about the cosine? Cosine of x, and you're not going to use this triangle for the cosine, right? Because you need to use this for the cosine. So taking the cosine of both, cosine of 2 arctangent. Now which identity are you going to use for this? Notice that the double angle for the cosine is going to be what? Cosine squared arctangent. We're going to use that minus sine squared arctangent. Right? We're going to use this identity. Or you can use cosine squared of arctangent minus 1. I'm sorry, 2 times cosine squared arctangent of u minus 1, or 1 minus 2 cosine squared, 1 minus 2 sine squared of arctangent. You can use that, but I just want to use this one because I like it. So what is going to be the cosine? The cosine was this over that, right? And squaring that will be 1 over 1 plus u squared, right? Minus, now what is going to be the sine? Sine squared is going to be u squared over the input, 1 plus u squared. U squared over 1 plus u squared, right? So as a result, the denominators are the same. 1 minus u squared, 1 plus u squared. Perfect. Okay. So now this integral, let's separate this work. So this integral becomes 2 over 1 plus u squared. That's the dx part, right? Multiplied by 1 over sine x is where? It's this one, 2u over 1 plus u squared minus cosine minus 1 plus u squared, right? Because there's a minus sign. And because both the sine and cosine are divided by the same denominator, that's why I combine these two together, because they have the same denominator, right? And then let's see, and then minus 1. Don't forget there's a minus 1 there, right? this whole thing, minus 1 in the end, du. Let's take the 2 out. Let's see, so 1 minus u squared will be going on the top, so I'm sorry, 1 plus u squared will be on the top, 1 plus u squared. I'm talking about this 1 plus u squared eventually, right? And then let's see, 1 over, and what is going to be this resulting small denominator? U squared minus 1, so let's see, u squared, well, let's copy it down, so 2u minus 1 plus u squared minus 1 minus u squared du, right? So now these two guys are gone, so we will have what? U squared are gone, 2u minus 2, 2u minus 2 du. So we can take the 2 out here, so 2 over 2 u minus 1 du, right? The 2's are gone, so we're faced with a simple integral, right? So now this is easy, right? V is u minus 1, dv is just 1, nothing changes, no other numbers, you're looking at ln. So ln of absolute value u minus 1 plus a constant. Switching back to x, we get ln of absolute value u is tangent, right? So tangent of x over 2 minus 1, don't forget absolute value closed, plus a constant. And so this is your resulting antiderivative. I hope this was a lot of fun. Thanks for watching, and see you in the next video.